Here's the thing about buildings. Even with the best design and planning, they almost never perform as intended. The gap is real and it's addressable. Every episode, we get into the building science with the people closing it. This is Building Performance Unlocked.
Hello, everyone. Welcome to the Building Performance Unlocked podcast from Aeroseal. This is actually our first episode of many, so thanks for being with us as we kick off this ongoing podcast series. I'm Bill Shaddad, and I'll be the host and moderator. We're really glad you're here. We hope you'll also view or listen to our future episodes in addition to today's. Today's episode is titled Ventilation Rehabilitation. We're going to be talking about what ventilation rehabilitation is in existing buildings, why it's important, how much opportunity exists out there in the marketplace, and the benefit it provides, both for building owners as well as the people who occupy those buildings. Because after all, let's always try to remember that we're responsible for providing better built buildings for the people inside those buildings. So with that said, I'd really like to welcome our guest speakers today, Chuck Hector from RSI and Tom Holmes from Aeroseal. Both Chuck and Tom have decades of experience in this topics and the buildings industry and are very well recognized experts in the field. I'll also personally add that I think you're going to enjoy this conversation. Chuck and Tom sometimes can be a little bit of a yin and yang, a comedic duo. So I think we'll have some fun conversation as well. So Chuck and Tom, if you guys could give the audience a brief overview of your backgrounds, we'd appreciate it. Maybe start with Chuck and then Tom, you follow.
Hi, everyone. My exposure to the industry started about 30 years ago doing air duct cleaning for both commercial and residential buildings. And about 15 years ago, we were introduced into, instead of air duct cleaning, more building performance and specifically sealing of both ventilation systems and exhaust systems. Recently, well, in the past 10 years, we've really concentrated on high-rise multifamilies in the New York marketplace and trying to develop a lot of standard operating procedures and best practices in that industry. Luckily, Tom was a part of our SI for quite a number of years, and we were able to work on setting up these standard operating procedures at about 10 or so years, 12 years ago, maybe? Yeah, about 12 years ago. So we've got a lot of experience on a lot of buildings. We've gone through the trials and tribulations, but basically the whole time we've been together, we've been finding out ways to, figure out the best ways to take a look at a building and do what was necessary in terms of investigating what the problems are in buildings, coming up with solutions that we're able to rectify those problems, and then coming up with appropriate documentation once we were done to show that the work that we had done had actually proved itself in terms of energy performance in other areas of the building.
Well, I'm Tom Holmes. Chuck and I, my history started with building envelope, a big building air sealing work. And it was sort of at that connection that Chuck and I first encountered each other trying to fix some high-rise apartment buildings. That was all during the Obama money, the 2010 to 2013, which was a great opportunity. A lot of what happened there was it created an environment where you could experiment, and that's what we were doing. We were kind of figuring out how to make buildings sort of less worse, even more than better. And then the last 3 years, we've kind of been back together. I'm working for Aeroseal, and Chuck is still with RSI. But we've been able to really build on what we initially worked on together, what we then developed independently, and now taking that back and bringing that into a culmination where we're well past making buildings less worse. We're actually making them better, and we've really, in many respects, figured out how to make almost any building with a central ventilation system work well, which is great.
Yeah, that's awesome. Well, thanks. Thanks for those intros. So let's start with the title for the session. It was Ventilation Rehabilitation. I want to ask you both, what work are we talking about there? And why isn't anything being done about it on buildings, or as much as we might think is a is good? Like, why is it happening not at a bigger scale? And then also, why is this so important for both building occupants and the building owners? Like a couple different perspectives there. So a lot of questions. Maybe start with what work are we talking about, and why isn't more of it happening today?
You want to take the first one? Or?
Well, I'll start it.
Okay.
So the buildings we're talking about are high-rise buildings where they take the utility spaces, things like kitchens and bathrooms in a multifamily, or just bathrooms and other, things like that in a commercial building, and they move them to the middle of the building away from the windows, because there's only a certain amount of windows that you've got in a building like this. And when they do that, those spaces need to be mechanically ventilated. They've been doing these for, really 100 years or whatever, but they've been doing them really in earnest since World War II. So mostly what we're talking about is buildings that were built, that were designed from about the 1950s up until about the turn of the century, this past century, about year 2000, maybe as far as maybe up to 2010, under what we tend to call the old code, which was sort of the common engineering principle of dig the hole too deep and fill it with too much concrete and nothing will fall over. Well, in ventilation terms, that's put a big enough fan on the roof and suck hard enough and everybody will get some ventilation.
Right.
This was, of course, started when coal was $4.50 a ton, $4.50 a ton. And nobody was really thinking about the implications of that, the energy implications of it. And then also, these buildings were leaky enough and drafty enough that they just sort of kind of went on. I think it's a neat. Everybody knows about the revolving doors that you see in the at the lobbies of a lot of high-rise buildings. Well, the reason that they exist is because these really, really big buildings, these tall buildings, have a huge stack effect, very dynamic pressure dynamics going on inside of them. And if you didn't have a revolving door in some of these buildings, you wouldn't be able to get in. It would take 3 men and a boy just to open, a hinged door to let you be able to get in and out of the building. And so, as we're looking at those types of environments, which means that if you try and make them less static pressure-y, if you try to make them exhaust a lot less air, they kind of, because of the dynamics, they kind of stop working. You kind of get sections where you don't get anything, neither fish nor fowl.
Part of the question too is, in terms of these ventilation systems that have been built over the past 70 years or so, the exhaust shafts are kind of the stepchild of the building. So you have water systems, you have electrical systems, you have heating systems, and then you have exhaust systems. And being the least important of those functional systems in a building, a lot of the exhaust risers were built in a manner that they were not sealed risers. So if you have a 30-story building, imagine that you have a riser that's 300 feet long that has a lot of gaps and holes and seams that are not sealed very well. When that happens, the lack of proper design within those areas is never going to allow the ventilation system to work properly. And so when you have an exhaust system that's not working properly, you're not having proper air transfer from the 30th floor down to the first floor. Mm-hmm. These are things that are known throughout the industry. Like, people know this. The next thing is, there are codes that are in effect that say you should have, let's say, 30 CFMs per kitchen or bathroom exhaust. And what happens a lot of times is you might have 150 CFMs of air being exhausted on the very top of the building and 30 or no CFMs being exhausted on the bottom third of the building. Once again, these are things that are known throughout the industry. But why aren't people being reactive to it? You have a code, you have the Department of Health that will go into a building and give out fines every once in a while if there's not proper airflow. But people don't react to it unless it's mandated. And so where you have these indoor air quality issues of air not being properly exhausted from the top to the bottom of these risers, or building performance where it's known, or codes that are in place to say exactly what is or isn't going to be done properly. Why then, over the past 70 years, has more not been done to change this? And ultimately, it's mandating, it's penalties. We always say, unless someone's being sued, or unless there's a whole bunch of grant money on the table to do this work, it's not going to be done. Even though everyone knows about the problem, if your lights weren't working from the top to the bottom of the building, the lights would be fixed. If your water was not working, the water would be fixed. But if there's no exhaust coming in properly from top to bottom, it's the stepchild. It's not going to be done.
Yep.
What's changing right now is the fact that the carbon footprint of the building can be greatly improved by doing this exhaust ventilation work and having it work efficiently from top to bottom. And that is going to be mandated in terms of local law 97 in New York, where high penalties are going to be placed on these buildings if they don't perform properly. So in a weird sort of way, what's going to improve your indoor air quality and what's going to improve your building performance is actually the carbon footprint. Is the mandating of the lowering of the carbon footprint is what's going to make ventilation being done more often, which then is going to yield better building performance and better indoor air quality. That's kind of a long answer, but that's the truth of what's happening now.
No, that's really good. And sorry, real quick, Tom, I think what we're talking about is the operational carbon impact, right? Meaning the carbon that's coming from how much energy we're using to heat, cool, ventilate, and power the building.
Yep. So the other reason that this doesn't get fixed is, unlike, if I wanted to reduce the energy cost for my common area lighting, I can put more efficient lights in, and that's just a matter of, you pull out a ladder and you climb up and you screw in the right light bulb. The ventilation systems in these buildings are buried. They're behind the walls. They're, they're behind tile walls in bathrooms. There isn't an easy way. You can't just start going in there, with a sledgehammer and bust down these walls in an occupied building and, expect to get out of there alive. You need to have a strategy. You need to have a solution that doesn't require taking the building apart to put it back together. Chuck and I have actually been involved in a couple of projects where the hot water, chilled water, basically the pipes for heating and cooling, where those systems go bad, where they rust out, and a pipe bursting on the 30th floor of the building, that's a $200,000-$300,000 insurance claim. And so we've been involved with buildings that have had to literally go in and replace all of those plumbing risers. And you're looking at, $10-15 million to do it. Incredibly disruptive. We're going to bust down the walls in everybody's living room. Absolutely horrendous when you really have to do it. And so if you don't have to do it, you won't. And one of the really cool things about these methods that Chuck and I have been working on, and a couple of other folks around have been working on, is you don't have to bust down the walls. The whole thing is done with very, very little disruption to the occupants, with very little visible construction work happening. And it can also be done quickly. It doesn't take 2 or 3 years to fix it. I can fix it over a summer and then see the benefits of it that winter, which is really quite cool.
And part of where we're going on this is, yes, we're within the built environment. So how are you able to fix these issues of leakage on these risers that go 300-400 feet within the built environment? And it's a number of tools that are used that are non-obtrusive in terms of breaking down walls, but ultimately Aeroseal is the final leg of that journey.
That's right.
Which allows you to get to a riser that is reaching targeted leakage without disruption of the built environment.
Yeah.
Got it. Cool. Tom, let me ask you a question from an Aeroseal vantage point or Aeroseal point of view. What does the existing backlog for ventilation rehabilitation, look like? Are there any numbers that you can kind of put on it that you've thought about?
What do you mean by what do you mean ventilation backlog?
Well, in terms of the number of projects, like how many buildings out there do you think where this could be done? Or,
In New York City, in New York City alone, there are probably 2,500 buildings. But if you think about it, it's almost more in terms of how many homes are you going to fix, right? If we're talking about
Right.
multifamily
Sure.
buildings, right?
Right,
These are
right.
people's
Yep.
homes.
Yep.
The average multifamily building that was built between, let's say, 1960 and the year 2000 in New York City is about 350 apartments. That's the
Yep.
average building. There are at least 2,000 of those buildings. So you're looking at, 750,000 homes that you can essentially make healthier, safer, more
Right.
energy efficient.
Yep.
That's sort of the scale of the work.
I like the
Now,
way you frame that.
how many buildings a year do you generally? You've been doing this, in New York
Yeah.
every year.
So we probably do about 20 buildings a year, some smaller and some
Yeah.
actually larger, but about 20 buildings a year is the number of projects that we work on.
Okay.
So if you're talking about the next 5 years, right, for what we're looking at a scope of the first 2,500 buildings, there are others after that.
Yeah.
But
Right,
so
right.
you would go up to like 400 buildings a year over the next 5 years that should be done, and
Right. Yep.
so it's massive. It's a massive number of buildings that should be done, that have the ability to have grant money to be done, that
Right.
would be greatly improved on every level to be done. So we're going from, let's say, a total of maybe 40 or 50 buildings a year in New York City that have these kind of projects, to where ultimately the backlog could be 400 buildings a
Yeah.
year easily over the next 5 years.
Well, and
Yeah.
the other thing, think of how selfless this guy is, right? He's got essentially 100 years worth of work laying out before him. And he's here sharing all of this with everybody so that other people can get into the market and so that the work can get done faster. He's going to run out of work in 25, 30 years. I mean,
Well, given those numbers,
he's a prince among men. He absolutely is.
aside from that, the reality is, and this is something that Tom and I have worked on very hard over the past 10 or 12 years, is that for those buildings to be done and for the engineers to be happy,
Yep.
Stephen Winders, N-Power, Bright Power, et cetera, for those engineers to remain happy, these projects have to be successful.
That's right.
So it's not about what RSI can do. My interest is, can we develop great standard operating procedures for the industry to follow, so that we can do 400 buildings a year, so that other people doing this work don't fail.
Yes.
At which point
Yes.
the engineers don't want to do it, and et cetera, et cetera.
Yep.
Most of what's happened with Aeroseal, especially in the past 10 years, and with our company working together with Aeroseal, is that we are trying to define the standard operating procedures that will extend the durability of this work for the next 20 years, right?
Yep.
And it's crucially important, so it goes well beyond what RSI can handle. But if we don't have good standard operating procedures, which we know now, we have these we know what to do, we know how to do it, we know the materials and equipment and procedures and inspections and reporting at the end. We know all of these things now. And so part of this podcast is, how can we go out and be able to share that with as many contractors,
That's right.
engineers, et cetera, in the marketplace to have these standardization.
Right. Yeah. What I like about this too is, Tom, I like the way you frame that in terms of like how many apartments or condos are there in a multifamily building, because we're talking about making better homes for literally hundreds of thousands of people. But Chuck, let me ask you a
just in
question.
New York.
That's just the New York
That's
market.
just
Well, I
in New
understand.
York.
Understand.
You've
Yeah,
got
that's just New York.
Boston,
Yeah.
Chicago, Washington, D.C.
Right. All over the country.
All over
yeah.
the country. Los Angeles,
Yep.
every place.
Yep. So Chuck, you're in occupied buildings every week. What do you think the gap is, in between, say, what the owner thinks the ventilation system is delivering versus what you actually find when you get in the building and measure it?
So a lot of owners know that the exhaust ventilation system specifically, not the total ventilation systems in terms of other kinds of heating systems or whatever, but kitchen and bathroom exhaust. These are well-known, well-defined problems that the owners know about. I always say it's three parts. It's the inspections and then the fulfillment and then the documentation. But the inspection part of it is we take videos of every single riser so that we know what we're going to do, but almost more importantly, so that the owners can see what is actually going on that's making this an inefficient system. So the ability to document blockages, to document laterals going in with wide gaps around them, to document breachways where people have knocked down bathroom walls that they have to redo the plumbing with. The cumulative numbers of gaps. When you have a riser where sheetrock is put between every single floor for 30 floors, and there's a 1 inch or a 3/4 inch gap at the top of each one of those risers where the sheetrock is. And when you take that ability to document that through a video, to do snapshots of that, to be able to present it to an owner, then it goes to the next level where now they can understand what the problem is.
Right.
And before, they just understand there is a problem.
Right.
The next thing is doing this investigation video and photographic and documentations that has to do with anemometer readings for the CFMs, or manometer readings with the static. We drop a manometer down the line, we can see exactly at this point you have no more static pressure. Why do you not have this static pressure? Because you've lost it through all these cracks and crevices at this point, which leaves no static pressure on the bottom. In a very simple way, I always tell everyone, it's not about CFMs, it's about maintaining static pressure from the top of the riser to the bottom of the riser, because static pressure is the horse and CFM is at the cart. If you don't have static pressure, you don't have CFMs. So you tell all of these stories to an owner at the point where they have to make an investment, and they see it's not just about putting a bigger fan up.
Well,
that's about fixing the riser.
That's right. Because these are essentially used air drainage systems. That's what we're talking about. And it's no different than any other plumbing system, right? We're moving
fluid dynamics.
Fluid dynamics, we're moving air. If you were to ask any engineer, any building super, anybody who works in a high-rise building, you talk to them about pumps, for example. Well, I need to have a pump that's going to produce, 15 psi per floor, hundreds of pounds per square inch by the time we get to the top of the building. And we need to select a pump that's going to have some headroom so that I'm not maxing out the pump, so that I'm sure that I've got the same exact set of rules for what we're talking about, but because it's air instead of water, you don't see when it fades.
So just
feel it.
To build on what Tom's saying, let's say you had that water system. This is all fluid dynamics. Air and liquid are all fluid dynamic. So you had that same piping system. And because it's a pipe, let's imagine that there were holes and leaks at every single, joint. And then you're saying, well, why aren't we getting water on the top floor? Well, everyone would know it's because we have these 87 joints that are leaking all of this water. Now you go to a riser and you say, well, why am I not getting airflow? It's fluid. It's the same thing. Your conduit is the riser. Your conduit in the water example is the pipe. If your pipe is not completely sealed, then you're not going to get the pressure. If your riser is not completely sealed, you're not going to get the airflow.
It's like trying to drink from a cracked drinking straw.
Yeah. I mean, one could say, how many holes would you like in your pipe? Right.
How many holes?
Zero.
How many holes in the bottom of your boat do you want me to leave before you go out in the ocean? Yeah,
exactly.
Yeah, the answer is zero. Exactly.
Right. Exactly. So here's a question, just when we think about different building types, right? And we've kind of hit on this a little bit. We've talked a lot about residential multifamily towers, right? But when you think about different building types, where would you both say this is needed most right now? Is it that multifamily residential, or is this also like an issue that needs to be resolved in K through 12 schools or healthcare facilities like hospitals, office towers? Who really needs it the most?
Almost every big building needs to be commissioned and recommissioned, right? There are actually even local laws in New York that kind of require that to happen periodically. There are all kinds of reasons for improving the building performance of any type of building. A lot of commercial buildings, a lot of the big commercial buildings with curtain walls, they don't have operable windows the way that apartment buildings do. They get all of their air exchange through mechanical ventilation. And there are tremendous opportunities for those owners to be able to save a lot of money and for them to improve the overall performance of their buildings for their tenants when they optimize the ventilation systems. In schools, there have been studies done. There was a really big study done in Sweden, got to be 20 years ago, something like that, where they were able to document that if the students got a better air exchange, basically 15 CFMs per student to 45 CFMs per student, it increased the performance in standardized testing by 7 points. And so that's not just a little bit of a change. That's a huge change because you're talking about going from an average grade of 80 to an average grade of 87. Look at that. That's huge. And so in schools, it's about that. In hospitals and healthcare, for them, it's all about infection control. It's all about controlling air pressures in the building, compartmentalization, and managing those airflows and maintaining healthy indoor air quality. And the more you can do that cost effectively without a lot of waste, the better off they're going to be. So any kind of building needs to look at the airside solutions that are available for their buildings, and they can make a huge difference. I mean, in a multifamily, we focus on the multifamily buildings. We have focused on them as much as anything because the solution is relatively homogeneous. It's a rinse and repeat kind of thing in many respects. Yep. And it also can be pretty dramatic. And you can actually reduce the energy footprint, the heating and cooling energy footprint of a building by 15, 20, 25% with this one measure. And since it's such a load shedding measure, any other work that the building would want to try to engage in, anything else they want to do for their next steps, is going to be so much more effective if you do these early load reduction steps that we do.
Just to go back and answer some of the questions about these other building environments other than the high-rise multifamilies, that's kind of my bread and butter, is the fact that from my vantage point, for the newly built environment, the new construction, there are great strides forward in terms of getting these ventilation systems, whether they're exhaust or supply ventilation systems, to work at their optimal level. And there are a lot of people doing testing on these buildings before they're certified to make sure that these systems are working at their optimal level. The built environment, there's almost nothing being done. The new construction environment, there are fabulous things that are being done. Within what we're doing specifically in terms of the high-rise multifamilies within the existing historical built environment is very, very exciting, because there's much more of this work being done within the high-rise multifamily environment than is being done in existing schools, hospitals, and existing commercial spaces.
The other really important thing, if you look at New York City, 80%, 87% or something like that of the buildings are residential buildings. Right?
Right.
I'm not sure. I think that's buildings. It's not necessarily square feet, but there is more square footage given over to the multifamily than there are to office buildings and hospitals and
Yeah, I think what's really, exciting about this too is that with the great work that you guys have been doing, we're still kind of just scratching the surface, right? We're
scratching the surface,
and there's a ton of opportunity left. Let me ask you as well. So here's another, interesting thing to talk about, and that is building owners, right? When building owners, and we've touched on this a little bit, but I think maybe we can drill down into a little more detail in some brief conversation here. So when owners hear ventilation rehab or ventilation improvement, they often might think immediately about shutdowns, either of the building or sections of the building at a time, and then maybe angry tenants. walk the audience through here what this work actually looked like when it's done well in an occupied building.
Okay.
I'm going to take the first whack at it. I'm just talking about specifically going into the unit owners.
Okay.
Right.
Like an
all
apartment.
The work we do with the ceiling and this and that and the other thing. So basically, when we look at let's say we go into the A line, and each A line apartment has a kitchen and bathroom, and it's a 30-story building, and we're just going to do the A line in this week. Okay. And so when
you say A line, is that one vertical riser?
Yeah. So if you go to the floor of the apartment, it could have A, B, C, D, E, F, G, H, I, J, K as all of the apartments that are on that floor. And those normally coincide with everything going all the way up that riser. That would be all the A's. Not always, but just in general, let's say that's the case.
For this illustration.
So we would do all of the A apartments from floors 30 through down to 1. We would go in a vertical fashion when we do this. And that's because there's a fan up on the roof that's attached to these two risers, two different fans, a kitchen and bathroom fan, tied to two risers up on the roof that service all the way down those 30 stories. What we would do is we would probably take 15 floors at a time. The first day we would do the top 15 floors, the kitchen and bathroom in those top 15 floors. We would take out we take off the existing register, the existing maybe or maybe not fire damper that's in there. And then we would go in and we would install a sleeve that we would seal with different kinds of caulk and mastic that would go between where the kitchen and bathroom is through the little lateral to where the riser is. We would seal that riser. We would go in at that point if it was if it was a floor by floor where you had a slab and you had sheetrock, we would go in through the register itself and seal that area that's open right between the sheetrock and the floor slab. We would install a sleeve. We would install a back plate that ultimately a constant air regulator would go into, and we would tape around that area. So every single floor, it would be completely sealed from the bathroom or the kitchen to the riser and up above that riser area.
If I could just interrupt. And what he's talking about in the apartment is maybe a half hour, 40 minutes worth of work.
So typically, let's say at most an hour.
Yeah.
So in the beginning of the week, one out of that Monday or Tuesday, the top half would be an hour on Monday. The bottom half would be an hour on Tuesday. That would be the exposure. On Wednesdays, we would go in and we would clean those risers and we would aeroseal those risers. That's on Wednesday. We would go up and down the floors, the whole 30 floors at that point, making sure that no one had any excessive leakage. If there were, we would go in and air those apartments out and be reactive to those. But normally, we would not be in any of the apartments on Wednesday. Then on Thursday or Friday, we would go in for less than an hour, but let's say another hour. And we would then put in a fire damper and a register and a constant air regulator, fire damper, and a register. So the exposure to the tenants or the condo owners would be, basically tops 2 hours a week exposure in their units.
Very minimal.
And owners think it's going to be much more onerous than that. And it's really not.
Yeah.
No, it's very non-disruptive. Mrs. Jones can be right there in the apartment while we're doing the work. It's not disruptive to them, and because they get inspected beforehand, because there's a very specific path that these things take. It's actually designed every step of the way to minimize the impact on the occupants. And it is very much designed to minimize. And the other thing is the occupants already know my ventilation sucks and not in a good way. They already know I'm not getting the air that I'm supposed to get. Or, it sounds like a wind tunnel in my apartment because I live on the top floor. Whatever it is, they already know that this is a dysfunctional system. And when you go in, I just had a meeting for a project a couple of weeks ago, and the head of their tenants union came in really loaded for bear with this. With an industrial hygienist came in with her that she had hired to talk about, what is this going to be like? And, are you going to be doing this? Are you going to be doing that? What's going to happen here? What's going to happen there? And at the end of that hour-and-a-half meeting, and she was tough. She knew exactly what she needed to know to be able to be a good advocate for her people. At the end of the hour-and-a-half, I said to her, so Janet, does this feel like a project that you could get behind, that you would endorse? I needed to know, what am I facing? And she said, oh, no, this sounds great. When can you start? Which is great. It's music to my ears. And I shrugged and looked at the property manager and said, I don't know, when can, as soon as I've got some paperwork, I guess. And so she turned to him and she said, Andre, when are you getting him his paperwork? So the occupants really, in general, once you get a chance to explain how it works, the occupants really kind of like it because it is something that's being done to make it better for them.
Right.
It also happens to be better for the building because it's going to save them a bunch of energy. But the building performance piece is one of the things that differentiates our work from so many other energy saving things. Is it's actually not just about making the building run cheaper. It's about making the building run better.
Right. Yeah. No, it makes sense. So let me ask you guys then, what do you think's standing in the way of more of this happening? Is it primarily a budget problem? Is it a knowledge or education problem? Is it a contractor? Is it a capacity problem? Well, hang on.
I think the key thing that's really held it up so far is the lack of a podcast.
when we've gotten into this, it's not the knowledge that the building is not working well, and it's not even not understanding why the building isn't working well. It's with all of the things that a board has to spend money on to improve their buildings. Even though they know there are significant indoor air quality issues and whatever, they have a certain amount of money to spend over a certain amount of years. If they're being sued, they'll be reactive. If there's grant money for this, they'll be reactive. And that's the biggest difference between doing this work or not doing this work. Now, for example, there are very large property managers right now, some of the biggest in New York City, who are looking at this work, and there's a project that we're involved in that's two 49-story buildings right next to each other. They're managed by the largest property manager in New York City. They are very interested in doing these buildings and using them as a proof of concept. And then they have 40 other buildings that they want to introduce to this work because they want to get the money grants that Con Ed is having available as quickly as possible to make sure they have that money. Now, 5 years ago, they didn't want to do this work. They knew what the issues were. These issues have been in these buildings for
Since they were built.
35 years. They've had these issues on the buildings. But right now, they want to do these two buildings, and they're talking about doing another 40 after that, as soon as the proof of concept works, because there's grant money on the table. That's kind of an answer to your question.
And then
no, it is a good answer. It's a stick and a carrot.
That's right. And then the other thing is, even without any incentive money, the return on investment for these projects is typically 7 to 10 years, right? Which is, if you're in a buy and hold kind of mode, it's a pretty reasonable ROI, right? But it's also something that costs $3,000-$4,000 per apartment to do.
Mm-hmm.
So somebody's got to write $1 million check to be able to see then $150,000, $200,000 a year benefit. And so, those things are a barrier. Now, Con Edison, to their credit, they had come up with and have tried and been experimenting with some financing tools. We at Aeroseal are doing the same. Ways of being able to say, okay, we can reliably tell you that you'll save this kind of money every year. How do we set a payment that looks like that? You're going to spend this much money. Why not spend it on a payment for 5 years, and then you get the benefit, rather than keep spending more and more and more as these costs go up, literally 10% or more, or 15%. And I'm sure everybody's been seeing all the talk about the impact that data centers are going to have on utility bills. Yeah,
I'm just going
these
to
are huge things.
say one other thing in terms of where the market is and where it's going. 5 years ago, and what we did with incentives from Con Ed, there was $0 in the bucket for the work that we did.
Right,
There was incentives for other
for
things.
lighting and
This work that we do, which is bunched into a lot of other projects like it, there was $0. 2025, they had $20 million in that bucket. Not all went to exhaust shaft weatherization, but they had $20 million in that bucket. By 2030, that bucket is going to have $135 million in it. Con Ed is saying their biggest issue right now is, do we have programs and qualified contractors to be able to do this work? We have the money. We need qualified programs and qualified contractors to do it. So as we're looking out over these next few years, that's the landscape. 5 years ago, 0. 2025, 20 million. 2030, 135.
Got it. So that's awesome. So let me hone in on something here. If you could, without naming a specific project or building owner, is there an example where you can say, hey, here's a project we did, maybe a recent example where you say, hey, here's what the outcomes were, like these were maybe the dollar savings. Was there any measurable savings in indoor air quality or comfort? So beyond, and maybe start with energy savings and translate that to dollars if there's a recent example you can think of.
I'm going to let Tom take this, but what I'm going to say is that steam is a very, very expensive energy in New York City.
Yep.
And local law 87 graded buildings, A, B, C, D. And so the project that Tom's going to talk about right now that had fabulous returns was a steam heated building. And right now there are 65 high-rise multifamily steam heat rated at D or below on the rating system for local law 87.
Yep.
And Tom's going to talk about the project that was just completed and how that fared.
Okay.
Yeah, let's go ahead and do that without really getting into say project.
No. Well, so I'm gonna basically back into the energy savings piece of it. The work generally gets done. Savings is a critical piece, but it's not the only piece. It's the I'm getting poor ventilation piece. It's the I can't open the front door piece. The garbage room is backdrafting into my garbage chute. I'm getting cooking smells in my hallways. It's those kinds of issues that go away when we do this work. Even things like cooking and smoking odors, right? In New York, for example, weed is now legal. And so there's an awful lot more weed getting smoked inside than there used to be. And there's a lot more in the way of complaints. And buildings that haven't put in or aren't able to put in formal non-smoking, become formal non-smoking buildings are really kind of trying to deal with that. The work that we do fixes a lot of that stuff. It also, in the case that we're talking about, all of these things were true. And the building had been trying a bunch of different things. They'd replaced all their windows. They actually replaced all their fans on the roof. And they found that when they did that and then tried to turn them down to save the fan energy, the whole ventilation system more or less stopped working. And so they had to turn them all back up again. They lost that energy savings. When we went in and did our work, we were able to document for them almost a 25% reduction in the energy necessary. It's a 2-pipe hydronic system that's driven by steam or powered by steam.
Yep.
Just in the first year.
What'd that translate to in dollars? 25%. What's that mean in dollars?
A little over $200,000
in 1 year
against a project that was less than $1 million.
Got
so about a 5-year straight up ROI, and that's before the incentives were kicked in, right?
Correct.
So this is just independent standalone. Now, very much your mileage may vary, but because our work sheds load, it's a very, very reliable thing. We have another project that's just at the beginning stages, and this is a place that already did do the electrification. They did put in air source heat pumps, but they're not getting the benefits that they expected. And part of the reason that they're not getting the benefits that they expected is that their ventilation system is still fairly dysfunctional. And they did replace the windows as well. And the combination of now the tight windows and envelope and these heat pumps, they're just not, the whole building has gotten very negative in pressurization, which is actually causing them to become negative in their attitude as well, because they're not happy with it. But they didn't see the kind of savings they expected from the heat pumps.
Mm-hmm.
With the work that we're going to do, heat pumps become less efficient the colder it gets. This was an unusually cold winter, so they really got kind of spanked that way. Our work becomes more efficient, more impactful the colder it gets, because we're reducing the amount of air that has to be brought back in, heated up, and then exhausted from the roof. There, we're expecting probably a 15 to 20% reduction in the energy to heat the place. That's a big deal. And that's something that we're getting to where, with the precision of the models that we're building up front, with the level of diligence in our test in and test out to be able to really track the data. And then we also track the bills for a year. We're able to really empirically say we're saving this energy. It's not, we think we might have been saving this energy.
Right. Yeah.
Right?
Yeah.
And
Gotcha.
that's becoming a big difference for the work we're doing.
And in some of the examples that you're talking about, people have made investments in trying really to improve their buildings, so the energy performance of the buildings. And unless you do buildings are very dynamic, you know, and so every factor relates to another factor in the building.
The knee bone's connected to the thigh.
So they've done things with fans, they've done things with heat pumps. These are all great things that they've done to the building, but they can't work at peak efficiency if you don't take the lungs of the building, you know, the airflow and whatever, and manage that also. Right. So it's made these very good things that they've done to the building very inefficient for very high costs, you know, and by making the whole building work in simpatico between the ventilation and the heat and the air exchanges, all of a sudden now the whole building works efficiently at higher rates of energy performance.
Got it. Yeah, makes sense. Well, guys, I got one or two things I want to touch base on. The first is from an engineer perspective, or a project manager perspective, or property manager perspective. For those folks in those jobs that are listening, what should they be measuring and specifying differently on their next energy retrofit for an existing building?
The home run for all of this is changing the gross exhaust flow from the roof. Because these are exhaust systems that we're mainly dealing with here, the energy doesn't get lost until it leaves the building. And the energy gets lost at the fan. So you need to measure, and that's one of the big things that we do. How much gross exhaust flow am I getting from my current fans now? And then you need to, at the end, measure the same thing. One of the reasons that Aeroseal is such an effective tool for making these things work is that it does do the last mile. If I've got a self-balancing flow control device at every vent, which Chuck was saying that we install, and I can reliably say I've gotten it down to 50 or 30 CFMs of leakage in the entire riser using Aeroseal, which I measure when I do the work, then I have a really known amount of air that's leaving the building. And so that's really where the home run is it's changing that gross exhaust flow.
So every CFM has a dollar coefficient, depending on whether it's oil, gas, electric, or steam. So every additional CFM that's released into the air has a dollar coefficient. The very interesting thing here is static pressure in that riser. Where you have leaks in the static pressure in the riser, your riser has less static pressure, which means your fans are actually exhausting more than original design. So if that fan originally was designed at 0.75 static pressure and X amount of CFMs up and down the line, and with all of these leaks, instead of having 0.75, on average you have 0.2 static pressure, you'll be exhausting 30% more air than the actual original design of that fan, which every CFM has a dollar coefficient to it. So what you're able to do when we do these, a lot of fans in kitchens or bathrooms. Kitchens, sometimes these fans, like on the project that we were talking about, the steam heated building, was 100 CFMs as the fan design.
Right.
It's 50 CFMs in the kitchens.
In the bathrooms, yeah.
In the bathrooms. The bathrooms in the kitchens, that 150 was reduced down to 60 or 70 CFMs. So for every apartment, you had whatever that differential is, 70 CFMs of dollar coefficient for every CFM exhausted. Now, part of the problem is, even at that 30% more design that was being exhausted, you weren't getting airflow on the bottom 30% of your building. So you had 30% more airflow with zero. Now what we've done is we've taken that airflow, we've reduced it by design by 50%, which is even greater than what the actual was because of the lack of static pressure in it. We've reduced the design by 50%. We've gotten equal airflow from the top to the bottom of the system. And now this system is sealed, so you're able to get that static pressure from the top where the fan is all the way down to the bottom of the riser, and you have airflow coming in from top to bottom. That's kind of what we do. That's in a nutshell of what we do.
Got it. Okay. One last question, if we can quickly answer that. If we look out over the next 24 months, who do you think has to move first on projects like this? The building owners, the building operators, like the property managers? Is it the construction trades? Or is it the regulators, so that the work that needs to be done can actually happen?
I think the regulators have largely, they've already taken their stand. You know, what you see in New York is with the local law 97. In Boston, it's BERDO. It's a similar thing in DC. So they've already kind of drawn the line in the sand, and they've set dates to it. The owners and operators of the buildings are all scrambling to try to figure out, you know, which of the things that I could do, should I do? Yeah. And that's being driven in part by, you know, how much money do I have in my reserves? Right. If I, you know, all I can afford to do is make my lighting a little bit more efficient. That's all I got. That's all you got. So I think the next thing is for the utilities, because there are the incentives. Chuck was 100% right. Being able to make this stuff affordable and make it so that these fairly substantial investments can be spread out, not over the entire life of the measure, because this stuff, the stuff we're talking about lasts, 15 to 20 years, and really the weak link are the fans you put in. They're the ones that's the part that's going to wear out first. So, you know, the standardizing, and we're actually working really closely with Con Edison in New York and with Eversource and National Grid in Massachusetts to do this, to get the standardized work scope really well defined, to get the measurement and verification strategy really well defined and able to be executed. And then the next step is going to be to build out the workforce. Now, Chuck, nobody's ever going to be able to say they've been doing this longer than Chuck, because Chuck's been doing this longer than anybody's been doing it. And he's always cruised. Well, no, so some of the guys that are working with him today were already seasoned guys when I was working with Chuck, 10, 15 years ago.
Yeah.
And so these are people, you can't replace that level of experience. But by standardizing the work as much as we have, it then provides the necessary point of entry for other people to come in and start to do this work properly. Because that's it's always been the biggest challenge with this, is you get some guy who goes, how hard can it be? You're just sealing a duct. And then they go here and they totally screw up the building. And then everybody goes, oh, well, that stuff doesn't.
Going backwards, and also to take another point of the question is I think the biggest differential right now is, and through Aeroseal, working with Con Ed, they're coming up with a standard program that Con Ed is comfortable with.
Yeah.
And so when I was talking about a bucket of $20 million going to 135, when Con Ed finally, right now, the cake's been made, most of the icing's on it, and we're just ready to put the cherry on top to finish this thing. And so that's about where the process is with Con Ed, getting to a comfort
And
NYSERDA, I'm sorry,
Yep.
and NYSERDA, to get to this comfort level to say, yes, let's fully move forward in terms of these ventilation projects. That's the biggest piece of the puzzle, because then you have companies like who are waiting right now, energy engineering firms like NPower, Bright Power, Stephen Winters. They're just waiting right now for all of this stuff to be signed, sealed, and delivered, so they can go out to their clients to be able to show them these products at these returns with these standardized inspections, jobs, and documentation. And the whole thing's going to flow at that point.
Right. Great. Well, guys, I think we've gone through a lot of information today. Thanks so much. I know I've learned a lot. I've enjoyed it. I think our audience has too. So thanks again for your time and for sharing your expertise and years of experience with us. Just want to remind our audience to please look for additional episodes in our ongoing podcast series. Our next episode is called Code is the Floor, Not the Ceiling, and really talks about building standards versus building science. But again, Chuck and Tom, thanks so much for your time today. I had a really good time listening. I learned a lot. Like I said, I think our audience did too. Any last, brief words of wisdom you might want to share?
Well, it's an exciting time for the whole building performance industry. And I think the next 10 years is going to outshine the previous 10 years, by 20-fold or whatever. So for anyone in the industry, for all the things that Tom was saying about doing things to improve the indoor air quality or indoor experience for condo and apartment owners, 600,000 of them in New York City, it's exciting times for everyone.
Yep, absolutely. Great. Oh, sorry, Tom.
I'd like to see more people with less gray hair getting into it. There are some younger folks that are really taking it, but this is really cool stuff.
Yeah.
I mean, at the end of the day, this is just cool stuff.
Yeah. It's been very exciting for Tom and I to have had the privilege of working within this industry.
Yeah. Yeah. I mean, and that's one of the things that has kept us together for so long is that we'll look at something and we'll go, ooh, this is cool.
Yeah.
This is, and our spouses, our significant others look at us and go, you're out of your freaking mind. But that's okay. We get us. We get us.
Yeah, exactly. We like it. That's good.
Yeah.
Well, thanks again to both of you.
Right.
I greatly appreciate it. And we'll look forward to chatting with you again in the near future.
Thank you.
All right. Bye-bye.
Thanks very much.
Bye-bye.
Bye.